Artificial intelligence is rapidly changing our world. From self-driving cars to virtual assistants, AI is already having a profound impact on our lives. At the heart of this AI revolution is a powerful technology transformer models. These models are transforming the field of AI. They are driving a wave of innovation in areas like natural language processing and computer vision. But how do transformers work, and what makes them so powerful? Transformers are a type of neural network. Neural networks are computer systems modeled after the human brain. They are designed to learn from data in a way that mimics human intelligence. Transformers are particularly well suited for processing sequential data such as text or speech. This makes them ideal for tasks like language translation, text summarization, and question answering. Transformers have quickly become the dominant architecture in AI. They power many of the AI applications we use every day. From Google search to ChatGPT, transformers are changing how we interact with technology and the world around us. Their ability to learn and reason from massive data sets has opened up new frontiers in AI research and development. The transformer model was first introduced in a 2017 research paper titled, "Attention is All You Need." This paper, published by researchers at Google, marked a turning point in the field of AI. It introduced a novel architecture for neural networks that would revolutionize how we process and understand information. Prior to transformers, recurrent neural networks, or RNNs, were the dominant approach for processing sequential data. However, RNNs struggled to handle long sequences of information. They had difficulty retaining context over long stretches of text or speech. Transformers addressed this limitation with a new approach: attention. The attention mechanism allows transformer models to focus on different parts of an input sequence when making predictions. This enables them to capture long-range dependencies in data. For example, a transformer translating a sentence from English to French can consider the entire English sentence when generating the French translation. This ability to attend to the entire context of an input sequence is a key factor behind the success of transformers. The introduction of transformers sparked an explosion of research and development in the field of AI. Researchers around the world began developing new transformer-based models and applying them to a wide range of tasks. This led to rapid progress in areas like natural language processing, computer vision, and speech recognition. The rapid progress in transformer technology is not solely due to the innovative architecture itself. Several key innovations have fueled the transformer revolution, pushing the boundaries of AI capabilities. These innovations have enabled researchers to train larger and more powerful models, leading to significant improvements in performance across various AI tasks. One such innovation is the development of advanced hardware, particularly graphics processing units or GPUs. GPUs are specialized electronic circuits designed to rapidly manipulate and alter memory to accelerate the creation of images in a frame buffer intended for output to a display. They excel at the parallel processing required for training and running complex neural networks like transformers. The availability of increasingly powerful GPUs has been crucial in scaling up transformer models to handle massive datasets. Another key innovation is the development of new training techniques and optimization algorithms. Training large transformer models can be computationally expensive and time-consuming. Researchers have developed innovative techniques like gradient accumulation and mixed precision training to reduce training time and resource requirements. These advancements have made it possible to train larger models on larger datasets, leading to significant performance gains. Furthermore, the development of new model architectures and attention mechanisms has played a vital role in advancing transformer technology. Researchers have explored various modifications to the original transformer architecture, such as the use of relative position encodings and different attention mechanisms like multi-head attention. These innovations have led to the development of specialized transformer models optimized for specific tasks, further expanding the applicability and effectiveness of transformers in various domains. At the heart of the transformer's power lies its unique architecture. Unlike traditional recurrent neural networks, or RNNs, transformers process entire sequences of data simultaneously. This allows them to capture long-range dependencies and relationships within the data more effectively. The key to this parallel processing capability is the attention mechanism, which forms the backbone of the transformer architecture. The transformer architecture consists of two main components, the encoder and the decoder. The encoder processes the input sequence, such as a sentence or a paragraph, and generates a contextualized representation of the data. This representation captures the meaning and relationships between the words or elements in the sequence. The decoder then uses this contextualized representation to generate the output sequence. For example, in a language translation task, the decoder would use the encoder's representation of the English sentence to generate the corresponding French translation. The attention mechanism plays a crucial role in both the encoder and the decoder. It allows the model to focus on specific parts of the input sequence when processing information. For example, when translating the word bank in the sentence "I went to the bank to deposit money," the attention mechanism would allow the model to focus on the surrounding words like deposit and money to determine the correct meaning of bank in this context. The attention mechanism works by calculating a weighted sum of the input sequence, where the weights are determined by the relevance of each element in the sequence to the task at hand. This allows the model to selectively attend to the most relevant information while processing the input sequence. Section 5. Out with the old. In with the new transformers versus RNNs and LSTMs. The introduction of transformers marked a significant shift in how we process sequential data in AI. Prior to transformers, recurrent neural networks or RNNs and their variants, such as long short-term memory networks or LSTMs, were the go-to models for tasks involving sequential data like natural language processing. However, transformers offer several key advantages over these traditional models, making them the dominant architecture in modern AI. One major advantage of transformers is their ability to handle long-range dependencies in data. RNNs, due to their sequential nature, struggle to retain information from earlier parts of a long sequence. This vanishing gradient problem limits their ability to capture long-range dependencies. Transformers, on the other hand, process the entire sequence simultaneously, allowing them to maintain context over long distances. Another advantage is the transformers' parallelizability. RNNs process data sequentially, making them inherently slow for long sequences. Transformers, with their parallel processing capability, can process information much faster, especially on modern hardware like GPUs. This makes them more efficient for training and inference, enabling the development of larger and more complex models. Furthermore, transformers have shown superior performance in various natural language processing tasks compared to RNNs and LSTMs. Their ability to capture long-range dependencies and process information in parallel allows them to achieve state-of-the-art results in tasks like language translation, text summarization, and question answering. The advent of transformers has led to a paradigm shift in AI, moving away from traditional sequential models like RNNs towards more powerful and efficient architectures capable of handling the complexities of human language and other sequential data. Section 6. Transformers in action, from language to multimodality. The impact of transformers extends far beyond the realm of language processing. While initially developed for natural language tasks, transformers have demonstrated their versatility across various domains, powering a wide range of AI applications. Their ability to process and understand complex patterns in data makes them suitable for tasks ranging from image recognition to protein folding prediction. One of the most notable applications of transformers is in the field of computer vision. Vision transformers have emerged as powerful models for tasks like image classification, object detection, and image segmentation. By treating images as sequences of patches, transformers can effectively capture spatial relationships within images, leading to significant improvements in accuracy and performance compared to traditional convolutional neural networks, or CNNs. Transformers are also making their mark in the field of drug discovery and bioinformatics. Their ability to analyze and understand complex biological sequences makes them valuable tools for tasks like protein structure prediction and drug target identification. By leveraging the power of transformers, researchers are developing new drugs and therapies at an unprecedented pace. Moreover, transformers are paving the way for more sophisticated and human-like AI assistants. Conversational AI models like ChatGPT, powered by transformers, can understand and generate human-like text, enabling more natural and engaging interactions with AI systems. These advancements are transforming how we interact with technology, making it more intuitive and accessible. The widespread adoption of transformers across various domains highlights their adaptability and potential to revolutionize diverse fields. As transformer technology continues to evolve, we can expect to see even more innovative applications emerge, pushing the boundaries of AI capabilities and transforming our world in profound ways. Section 7. The future of AI through the lens of transformers. The rapid evolution of transformer models has opened up exciting new possibilities for the future of AI. As researchers continue to develop larger and more sophisticated models, we can expect to see significant advancements in areas like natural language understanding, computer vision, and even scientific discovery. The future of AI, viewed through the lens of transformers, appears incredibly promising, with the potential to revolutionize various aspects of our lives. One promising area of research is the development of multimodal transformers. These models can process and understand information from multiple modalities, such as text, images, and audio simultaneously. This ability to integrate information from different sources allows for a more comprehensive and nuanced understanding of the world, enabling the development of AI systems that can perceive and interact with their environment in a more human-like way. Another exciting direction is the development of transformers that can learn and reason more efficiently. Current transformer models require massive amounts of data and computational resources to train. Researchers are exploring new techniques like meta-learning and transfer learning to enable transformers to learn from smaller datasets and generalize better to new tasks. Furthermore, there is growing interest in developing transformers that are more transparent and interpretable. As AI systems become more integrated into our lives, it is crucial to understand how they make decisions. Researchers are working on techniques to visualize and interpret the inner workings of transformer models, making them more trustworthy and reliable. The future of AI, powered by the transformative capabilities of transformers, holds immense potential for positive impact. From personalized medicine to sustainable energy solutions, transformers are poised to play a pivotal role in addressing some of the world's most pressing challenges. Section 8. Ethical considerations and responsible AI development. While the advancements in transformer technology offer exciting possibilities, it is crucial to acknowledge and address the potential ethical considerations associated with their development and deployment. As AI systems become more powerful and pervasive, it is essential to ensure their responsible and ethical use to avoid potential harm and unintended consequences. One major concern is the potential for bias in AI systems. Transformers are trained on massive datasets, and if these datasets reflect existing biases in society, the resulting AI models may perpetuate and even amplify these biases. This can lead to unfair or discriminatory outcomes, particularly for marginalized communities. Another concern is the potential for job displacement. As AI systems become more capable of performing tasks previously done by humans, there is a risk of job losses in certain sectors. It is crucial to address these concerns through education, retraining programs, and policies that promote a just transition to an AI-powered workforce. Furthermore, the increasing autonomy of AI systems raises concerns about accountability and control. As AI systems become more sophisticated, it becomes more challenging to understand and control their decision-making processes. It is crucial to establish clear guidelines and regulations for the development and deployment of AI systems, to ensure they remain under human control and align with our values. The ethical considerations surrounding AI development are complex and multifaceted. It requires a collaborative effort from researchers, policymakers, and the public to ensure that AI technology is developed and used responsibly for the benefit of humanity. Section 9. Conclusion. Embracing the transformative power of AI. The emergence of transformer models has ushered in a new era of artificial intelligence, one marked by remarkable progress in natural language processing, computer vision, and various other domains. Transformers have revolutionized how we interact with technology and opened up exciting new possibilities for the future. As we continue to explore the potential of transformers, it is crucial to proceed with caution, addressing the ethical considerations and ensuring that AI technology is developed and deployed responsibly for the benefit of all humankind. The transformative power of AI, particularly through the lens of transformers, has the potential to address some of the world's most pressing challenges. From healthcare to climate change, AI can augment human capabilities and accelerate progress towards a more sustainable and equitable future. By embracing the transformative power of AI while remaining mindful of its potential pitfalls, we can shape a future where AI empowers humanity and creates a better world for all.